Nickel steel. The addition of nickel to steel imparts great strength with considerable ductility and toughness. Steels with 20–30% nickel are highly resistant to corrosion by steam, hot gases and seawater. They have a low coefficient of thermal expansion. They are used for steam turbine blades, internal combustion engine valves, and for machine parts that are subject to wide ranges of temperature. Chromium steel. Chromium is added to steels which are to be heat treated. It gives hardness, good wear resistance, and increases the tensile strength and corrosion resistance of low alloy steels. Steels with 8% chromium are used in the manufacture of electrical equipment, and those with 15% chromium are used to manufacture springs, ball and roller bearings, etc. Nickel chrome steel. Nickel chrome steels are ductile, hardenable and wear resistant. They have good resistance to impact. Depending upon their composition, these steels can be mild, medium, high tensile or self-hardening steels. Mild nickel chrome steels are used in the manufacture of crankshafts and axles. Medium nickel chrome steels are used in cranks and connecting rods. High tensile nickel chrome steels are used in machinery components. Self-hardening nickel chrome steels are used in highly stressed shafts, tubes, gears, etc. Nickel chrome vanadium steel. The addition of vanadium to steel improves the mechanical properties and increases the effects of the other elements. About 0.1 to 0.2% of vanadium is generally present, and it helps produce sound ingots and is excellent in removing oxides from steel. Nickel chrome molybdenum steel. The addition of molybdenum reduces the temper brittleness of nickel chrome steels, or its tendency to become brittle when continuously exposed to high temperatures. This is used in making crankshafts. Silicon steel. Silicon imparts strength and fatigue resistance and improves electrical property. It is used in making springs, valves of internal combustion engines, etc. Tungsten steel. Tungsten prevents softening of steels at high temperatures. These alloys are called high-speed steels as they retain their hardness up to 6000 degrees centigrade, and intermittent heating to this temperature further hardens them. It is used to make high-speed cutting tools, permanent magnets, etc. Manganese steel. Manganese increases the hardness and tensile strength of steel and increases resistance to abrasion. It is used in making structural components. Tool steel. Plain carbon steels tend to crack during hardening. To overcome this problem, alloy tool steels or non-shrinking steels which contain high carbon, manganese, tungsten, and chromium have been developed. Typical non-shrinking die steel contains 1.5% of carbon, 0.9% of molybdenum, 0.5% of tungsten, and 0.75% of chromium. As the amount of the alloying elements is small, the steel is not very expensive and used for making dies and thin tools that need to be hardened.